All right, guys, let's look at some special cases of factoring. Okay, so we look at this one. It's a normal one where we can set up our x game. So set up your x. 36 goes on top. 12 goes at the bottom. So then you start looking at your factors. So 1 and 36 is not going to make 12. 2, 18, no. 3, I think that's like 3 and 13, but still not going to work. I'm not going to worry. 4 and 9, but then also, oh, wait, 6 and 6 work. Okay, and you can write them both as 6s. Okay, so we know we're going to use the middle, and it'd be written as x plus 6, and then x plus 6. Okay, so you can write it like that, or you also can write it as x plus 6 squared. Okay, that's another way to write it. Either way is right. This would be the most right, I guess you want to call it, and that's what you would see on any kind of testing. Okay, let's look at another one. So do the same thing. Okay, this is negative 14. So then looking, 1 and 49, obviously not. Some of you might be looking going, well, I know 7 times 7 is 49. And if I add 7 and 7 together, that gives me 14. But I need negative here, positive here. So that means both of these, if they're negative, would give me a positive 49. And then a negative 7 minus 7 will give me a negative 14. So then it'd be written as x minus 7, x minus 7. Okay, or once again, x minus 7, since they're the same, you could write it as squared. Okay, now you guys might be able to start recognizing some of these, since this is what's called a perfect square at the end of each of these. Okay, and it just so happens they're middles, because if they're perfect squares, and by that I mean if I did the square root of 49 is 7, okay, and if I put them together, they're going to add up. Same thing here. Square root of 36 is 6, and they happen to add up to that middle. So these are ones that are kind of perfect squares. Okay, if you don't remember what perfect squares are, these are a list of the perfect squares. Okay, I would write them down. They're going to become very important. I'd put them at the front of your notebook, back of your notebook, somewhere where you can easily find them. I would even pause it to make sure you write these down. Okay, because these are going to become very important. In fact, I forgot this is 11. Okay, and what I mean by perfect squares is when I find the square root of 4, it's 2, so 2 times 2. So that is what's a perfect. Sometimes you'll see some that are written like this, and that's not going to give me a perfect. That's going to give me a decimal. Okay, so these are perfects. Okay, like I said, take a second, write this down. Note card, front of the notebook, back of the notebook. Somewhere you can easily find it as a reference when doing this and other things we're going to start working on. You're going to need these. Okay? And here's why right now. Okay? We can factor these also. Okay? And the thing is, if you recognize that the end, you know, kind of going back to your chart, okay, if I recognize it, I see that 81 is a 9. And so basically what I'm going to do is, I'm going to square root these. Okay, so doing this, that means I have an x in each. Okay, and then the perfect square root is a 9 for each. And since it's negative, it's going to be a negative 9 and a positive 9. Okay. Now, I see over here I could, oops, sorry about that, guys. There you go. So it'll be x minus 9 and then x plus 9. So you kind of split the x's and then split the 9s. One's positive, one negative. Now, this is one, it seems like it wants to work, okay? But this one doesn't. So I'm not quite sure why I wrote it down because it can't be positive. But I'm going to show you why. Because if I did this, I'd put the x in each, right? Square root of 25, sorry. If I go back to my list, I can look for a 25 is a 5. But this is positive, so this would both have to be positive. But what's going to happen if I redid this? This would be x squared. This would be plus 5x. This would be plus 5x. And this would be plus 25. When I put these together, I get a 10x, so it's not going to go back. Okay? So if you see one like this, it's not factorable. Okay? Because, yeah, I could kind of do it, but it's not going to be a true statement. Okay? So this isn't factorable. So it's not factorable. You guys should not see any, so it should be okay. Okay, so but let's look at a couple more. I got x minus 49. They should always be like this. Okay, so going back to my list real quick. Let's see. I see 49's on the list, so it's a 7. Okay, so the same thing. Split them. X and an x. Then one's plus 7. One's minus 7. Okay, it doesn't matter order here as long as one's positive, one's negative. Okay, and just to recap that, think about it when we go through and factor it out. Minus 7x, this becomes a plus 7x, that's a negative 49. If you remember when we did these cancel each other out. Okay, so that's why it's x minus 49 and how you can get two binomials. Okay? All right, so let's take a look at this one. Same thing. We already know 36 is 6, so it's an x minus 6 and an x plus 6 because the square root of 36 is 6. Okay, once again, doesn't matter if this is negative or positive, as long as one's negative, one's positive. Okay. You guys also are going to come across some like these, where they're both perfect squares. Okay, so looking at this one, I see 9's a perfect square, so that's a 3. So I'm going to go ahead and put a 3 in each. Now, I'm splitting them into 2. So that means I got 4 of these, right? I could split them up evenly, so I'm going to do p squared and p squared here. Okay, do the same thing here. So I'm going to make one negative, one positive, because we already know we're doing this. Okay, square root of 16, 4. Then I got 2 of these, which means I can split them to be 1 in each. Okay, so if you have any questions, guys, don't be afraid to ask. Okay.